This is section 5.02 from Unit 5 Notes, Permutations and Combinations. Today I am, as in you are the student, discussing permutations and combinations so that I can determine if a scenario is a permutation or a combination. I will know I have it when I can solve problems involving permutations and combinations. Specific TEKS we're looking at for today's lesson is 8A. What is a permutation? A permutation is an arrangement in which order matters. In other words, if it matters in a list of 5 things, who I choose first, who I choose second, who I choose third, fourth, fifth, and so on. So in this scenario, how many ways can you arrange a set of items? Imagine 3 friends, Al, Bob, and Carl, sitting in a row. One of those permutations is Bob in the middle when Al is on the left, and then Carl is on the right. Switching Bob and Carl makes another permutation. So imagine these 3 friends, Bob in the middle. Al is first, Bob is second, Carl is third. Well, let's just switch Bob and Carl. Oh, that makes a new list if order matters, if it matters who's first, second, and third. Well, now let's say I want Bob in the first seat. Well, now I have Bob, Al, and Carl. That's a third permutation. Then I switch Carl and Al to make another permutation. That's 4. Bob, Carl, and Al. Well, now let's say I want Carl to be first and then choose the others in the whatever order I want. So Carl, Al, and Bob is a 5th permutation, and then Carl with Bob and Al is now a 6th permutation. So how many ways can we arrange Al, Bob, and Carl to sit in a row if order matters? So there's 6 different ways that we can do that. So that is permutation where order matters. Combination. What is a combination? Combination is an arrangement in which order does not matter. So I don't care who's first, I don't care who's second or third, and so on. I just want to put them all in a row, and that's that. So how many ways can you arrange a set of items if order does not matter? Well, for Al, Bob, and Carl, I just don't care who's first, second, or third. So there's really only one way that you can order them in a row. Al, Bob, and Carl. Even if I were to switch Bob and Al around, that doesn't make it unique in terms of combinations. I don't care about the order. I just want them in a unique row. And that's all you can do with combination. So regardless of the order in which they sit, the same 3 people will be sitting in a row. Since order does not matter, there's only one combination. As an aside, in 2009, if y'all were alive since around that time, 2009 Whataburger started their ad that that there are 36,864 different ways to order a Whataburger, and they gave that figure using combinations. A certain amount of ways that you can order your buns, your cheese, your protein like a chicken, beef, could be fish as well. I don't think they had fish, but another different type of protein could be veggie if Whataburger has veggie option. Your vegetables, lettuce, tomatoes, onions, etc. Your condiments, which is like ketchup, mustard, mayo, and others that they may have available, and other different options that I didn't mention. They calculated this number based on that info using combinations. Okay, just as an aside to spark your interest, or as a fun fact. Okay, so again, permutations means order matters. Combinations mean order does not matter. We're going to go through the calculations using the calculator. There is a formula to follow, but for our class, we're going to be just using the calculator to get the answers. So I'm going to show you all 2 calculators, the Desmos calculator and the TI-84. So the Desmos calculator, you could just Google that up. I have the link right here if you can read that. And just make sure you're using the EOC Texas version, Texas EOC version. Okay, so now to find permutation and combination on the calculator, you're going to you can type this up, but first we're going to find it in the keyboard here in the functions area. So you're going to hit this arrow to bring the keyboard up, and then you're going to click on functions. Then we want to scroll down to probability. Or I'm sorry, number theory, not probability, number theory. And you will see the NPR for permutation and then NCR for combinations. Okay, so let's say we want to do permutation. You click it, and then it'll give you that with the open parentheses. Okay, so let's say we want to find permutation for 10 and 8. Okay, so 10 is the N value, and then 8 would be the R value. Okay, so N is your pool of numbers. N is your pool of numbers, how much you're choosing from, and then R is what you're choosing. So let's say we have a pool of 10 things, and we're choosing 8 for permutation. Again, permutation is when order matters. So notice how we have 1,814,400 different ways of ordering these things if order matters. Okay, so you can go through the same thing with combinations by clicking on functions, scrolling all the way down to number theory, and then going to NCR. N, still the same thing, being your pool of numbers of what you're choosing from, and then R being what you are choosing. And then for combinations, order does not matter. There's only 45 unique ways of ordering these things or arranging these things if order does not matter. Okay, so again, notice how different NPR and NCR are. Now, if you know what to type, you don't have to go through the keyboard. You could just type those different things. N, capital C, R, open parentheses, and then type your numbers with the comma in between them. Close the parentheses, and it'll calculate it. And then if you want the permutation instead of combination, just use P instead. I believe that is it for Desmos. And now, let's say we want to calculate permutations and combinations using TI-84 instead. So, if you have a TI-84, you should have a physical one that they sent y'all through the supplies. But if not, if you go to the Practical Math course and you go to the content, underneath resources, you should see the download for a digital TI-84 calculator. So it's right there available for y'all with instructions on how to download it if y'all need it. Okay. So with the TI-84, to do this, we are first going to type in, well, first let me show you where to find it. So to find it, you're going to click Math, right underneath the alpha symbol, Math. You're going to go to PRB for probability, and then you will see option 2 for permutation, and then option 3 for combination. Okay? So, now to get through an example of how to type this up, I thought I had an example on the next page, but it didn't, so we'll just use these right here. So for example, let's say we want to type in 8 and 10. 8 being N, and then, 10 being N, and then the 8 being the R value. So you would first have to type the N value, which is 10. Let's say we want to do permutation. So we're going to press Math, go right to PRB, and then hit option 2. So 10, NPR, 8, which again, 10 is our pool of numbers that we're choosing from, and then R is how many we're actually choosing to figure out the different permutations. Excuse me. Press enter, and then it'll calculate the exact same number we got using Desmos. Okay, so if you want to do the same thing with combinations, again, first type in the N number, 10. Press Math, go to PRB, and then click NCR. And then choose option 8, or not option 8, choose or press number 8, hit enter, and then it gives us the answer. Again, combinations, the number is smaller because order does not matter, but when order does matter, permutations end up becoming very, very large numbers. And that's it for the TI-84 and how to use it. So you try number 1, and I have the steps up here for either calculator right above it. I want y'all to use the calculator instructions above to find each permutation and combination. So type this into whichever. What is 8 permutation 4? What is 8 combination 6? What is 6 combination 4? And what is 4 permutation 4? Okay. So if you need help, again, look at the steps right above it. It'll show you how to go through and get your answer. You can check yourself by removing this box to see both the Desmos and TI-84 answers. And then make sure you answer the boxes in here if you are using the class kick notes while you're watching the video. So at this moment, go ahead and pause the video. Try this on your own. Otherwise, I'm going to go ahead and show y'all how to do this. So starting with Desmos, 8 permutation 4, we need to first type in N capital PR, parentheses, and then you always want to do the pool first, which is the number on the left. That's 8. That's the N value, comma, the R value, which is to the right of the P4. Close your parentheses, and there, you'll have your answer. 1,680. Okay, so I'll use the TI-84 on the next one, just to go back and forth on each calculator. TI-84, what is 8 combination 6? I'm going to press math. Oh, I'm sorry. First, for the TI-84, I'm going to put the number 8, and then math, go right to PRB, choose NCR for combination, and then press 6. Hit enter, and then you'll get the answer as 28. 28 different combinations. Okay, and then I will use Desmos for this one. Except I'll show you all a different way. Instead, you could just simply change the P to a C, but I'll show you all using the keyboard right here. So to find combinations, you're going to click on the keyboard, you're going to go to Functions, scroll all the way down, and you can find NCR right there for combinations. And then you're going to type in for the pool, for the N value, 6, which is to the left of the C, comma, 4, and then close your parentheses, and there it is. Your answer is 15. There are 15 combinations when you have a total of 6 and you're choosing 4. And then finally, I'm going to use TI-84 for the last problem. Again, input the N value first, so you're going to press 4, then math, right to PRB, and then choose option 2 for NPR, for permutation. Then type in the R value, which is 4, and we have 24 different permutations of ordering, if order matters. Remember, combinations, order does not matter. Permutations, order does matter. And so when you do permutations, expect bigger numbers. When you do combinations, expect them to be more subdued. But either way, 24 is your answer. And that's it for you try number 1. Okay, now what the variables represent. If I didn't explain this already, here is your slide that explains it. Again, permutations, the number of permutations of R objects out of a total of N objects. N is your total, R is what you're choosing. Same thing with combinations. C is your combinations. Permutation order matters. Combinations order does not matter. Number of different ways to select numbers of objects from a group. Number of combinations of R objects out of a total of N objects. N is the total number of items. R is what you're choosing, the number of items to select. So that's what each of these things represent. Now, the next few problems, we're going to need to determine what is a permutation, what is a combination. There's going to be a series of questions that I'm going to ask y'all to help identify what each problem is associating with, or what's it talking about. So again, when finding permutations or a combination, when determining which one to choose, ask yourself, does order of the objects matter? In general, I've said this plenty of times, but I'm going to say it again because it's important. Permutations, permutation model situations where order matters. Combinations model situations where order doesn't matter. So let's look at you try number 2. And we're going to do this one together as an example. And if you want to try this by yourself before I go through this, be my guest. So if you would like, go ahead, read through the problems, through the steps. Determine which one you think is the best answer, whether order matters or doesn't matter. Is this a combination or a permutation? What value do we use for N and R? And what is the answer after plugging it into the calculator? Okay, so if you feel like you can do this, go ahead and pause it and try it on your own. But I'm going to choose this as our example to go through together, and then for the rest of them for y'all to do. Okay? So again, we're going to determine whether the following word problems are permutations or combinations, and then use the calculator to find the answer. In how many ways can a president, vice president, and secretary be elected from a class of 22 students? So, does order matter? Yes or no? Yes. Because we're choosing a president. We're not choosing one of the 3 for them to be randomly picked. We're specifically choosing a president first, a vice president second, and then secretary third. So, does order matter? Yes. So, because order matters, we are choosing permutation. Permutation matter, or is where order matters. What values do we have to use for N and R? Well, remember, N is your total value. So how many total students are we choosing from to fill these positions? We have a total of 22 positions, or students. How many positions are we trying to fill? We got president, vice president, and secretary. Those are 3 positions. So we're choosing 3. So now, what is the answer? This is, for permutation, we're choosing P. So this is 22 permutation 3 that we have to plug into our calculator. Okay? I'll show you all both. Let's go with Desmos first. Since we're using Desmos, we just need to type it in. N, capital P, then R, parentheses, 22, comma, 3. And then it gives us 9,240 different ways to choose the president, vice president, and secretary. I already forgot the number. 9,240. So 9,240 ways if order matters. That's Desmos. For TI-84, you're first going to type in 22, then press Math, go to PRB, choose option 2 for NPR, which is a permutation, and then put number 3, you'll get the exact same answer. 9,240 if order matters, because, and it does, because this is a permutation. It matters who we choose first, second, and third. And that's it. That's it for you try number 2. Okay, you try number 3. A basketball team has 8 players. How many different 5-person teams are possible if each player can play any position? So, A, does order matter, yes or no? B, is this a combination or a permutation? C, what are the N values and R values? D, what is the answer? So, if you would like, try this, pause the video, try this on your own, see if you can get the right answers. If you're on ClassKick, you can move the boxes and check your work. And just go ahead and try it on your own. Otherwise, I'm going to go through it and show y'all what the answers are. So, letter A, does order matter, yes or no? How many different 5-person teams are possible if each player can play any position? So, if we can play any position, does it look like order matters? Does it matter if I choose the first person, second person, etc.? No, it does not matter. I don't care who's center. I don't care who's forward, point guard, etc. They can play any position they want. So, no, order does not matter in this scenario. Because order does not matter, this is a combination. What values do we use for N and R? Well, how many total players do we have to choose from? We have a total of 8 players. What's the team composition? How many players are we choosing to make a team? Well, we're trying to choose 5-person teams. And so, R is 5. And again, I'm going to show you all using both calculators. I'll probably do it a little bit faster this time since I've shown this plenty of times. So I'm going to type in for combination N capital C R, comma, and then we're going to have 8. So 8 and then choose 5. 8, 5. And we have 56 different ways of making this team using combinations, if order does not matter. So we have 56. There's your answer. TI-84, for combinations, we have to put the number first, the N value, so 8, and then math, right to PRB. Option 3 for combinations. Whoops. And then for the R value, we need to choose 5, and then we'll get the same answer, 56. There's 56 unique ways, if order does not matter, to make a 5-player team from 8 players. And that's it for you try number 3. Okay, here's another example. You try on your own. How many ways can an artist hang 5 of his 7 paintings? This one's a little bit tricky, but I'm going to see if y'all can figure it out. What's your gut feeling say? There's not as many words to help determine whether this is a combination or a permutation. So I'm going to see if you can understand which one you should choose. So again, answer the questions. Does order matter? Yes or no? Is this a combination or permutation? What values do we use for N and R? And what is the answer from your calculator? If you would like, go ahead, pause the video, try this on your own, check your answers if you're on ClassKick and doing this while you're watching the video. Otherwise, I'm going to continue on and show y'all how to do this. Okay. How many ways can an artist hang 5 of his 7 paintings? It doesn't say order does not matter. Okay, if you're hanging 5 of his 7 paintings, here's one painting, here's another, and then another, etc. Okay, but then you could also switch the 2 in the middle. You could switch the outsides And so when I'm hanging paintings, I'm arranging them in a way where it matters what goes first, second, third, fourth, and so on. And so in the case of this example, yes, order does matter. It probably would have been better if it said arrange, but order does matter in terms of this. Now, because order matters, we have permutation. What are the N and R values? N is your total amount, so how many total paintings do we have? We have 7 total paintings. How many are we choosing to hang? 5. So, again, I'm going to go through the Desmos part pretty quick. Since this is permutation, we're going to choose, or we're going to input NPR, and then this is 7 out of 5 paintings. Our total number, if order matters, is 2,520. There's your final answer. Now, using the TI-84, we first need to type the number. So 7, math, PRB. We want permutation, so option 2, and then 5, enter. There it is. Exact same answer. Excuse me. That's it for you try number 4. Okay, you try number 5. Again, read the problem, pause the video, try this on your own, see if you can determine which, whether this is a combination or permutation, and then find your answer. Otherwise, I'm going to continue on and show y'all how to do this. Okay, so you try number 5. A pizzeria is offering a special. For $6, you can get a 4-topping pizza. Choices for toppings are pepperoni, sausage, olives, mushrooms, anchovies, peppers, and onions. How many different 4-topping combinations are possible, assuming that no topping can be repeated on a pizza? Meaning we're not going to do pepperoni 4 times, or we're not going to do olives 4 times. You can only use 1 topping once. So again, think about this. Does order matter? Yes or no? Doesn't matter whether you put pepperonis first, and then sausage, and then olives. No, you're eating the pizza. Pizza's a pizza. You don't care what order the pizza is made, as long as it comes out of pizza. So, order does not matter. Therefore, we have a combination. Combination order does not matter. So now, what values do we use for N and R? Well, N is the total number of toppings that you can have. It doesn't give us a number, so we have to count. The choices for toppings are 1, 2, 3, 4, 5, 6, 7. So we have 7 toppings to choose from. Now, we're getting a 4-topping pizza. So from those 7, we have to choose 4. And then we go through our calculator. Starting with Desmos, we want combination. So I'm going to type N capital C R parentheses. We want 7, 4 for our Desmos calculator. So 7, 4. And we have 35 different ways of ordering this pizza. There's your answer. Okay, TI-84. TI-84, you have to type the number, the N value first, and then go to math, right to PRB. We're choosing combination, so option 3. And then we're choosing 4 toppings from the 7. And again, you get this exact same answer, 35. That's it for you try number 5. Okay, the following 2 you tries, number 6 and number 7. I don't have the steps scaffolded at this point. I'm assuming you know what you're supposed to do. If you forget for number 6 and 7, just go back to a previous problem and just ask yourself these questions. Does order matter? Is this a combination or permutation? What values do we use for the n and the r value? And what is the answer? Okay, so I don't have it scaffolded like before. You'll just have to figure it out on your own. I just want the final answer from here. Okay, and as you're doing this, you can move the boxes to kind of check yourself if you want to see how to type it into the calculator. And then you can remove this box right here to see the hint for the n value and the r value. So if you would like, pause this video, try out number 6 and number 7 on your own, and answer them here in ClassKick if you're using ClassKick while watching this video. Otherwise, I'm going to continue on and show y'all how to do both of these problems. Okay, you try number 6, I'm going to use Desmos, and then you try number 7, I'm going to use the TI-84. So, in how many ways can 9 Olympic gymnasts, so we have 9 of these guys, win gold and silver matters? So, does order matter, yes or no? Yes, order matters because we're trying to figure out who comes in first and then who comes in second. Okay, so since order matters, we're using permutation. Now, from permutation, we need to figure out how many total we have. How many people are competing in this event? Well, we have 9 Olympic gymnasts. So our n value, n is equal to 9. Our r value is how many we're choosing from. And we're only choosing gold and silver, 2 places. So r is 2. Now, to type this into Desmos, simply type n capital P R parentheses 9 comma 2. Whoops. There we go. And we have 72 different ways of choosing first and second place for this Olympic event. So there are 72 outcomes for this event. There's your answer. You try number 7. Sydney has 3 brothers and 1 sister. She won a trip to the Texas State Fair and will take 2 of her siblings. How many ways can she choose her travel companions? Okay, so does order matter? Do I care whether I choose one person first or another person second, third, fourth, etc.? And nowhere do I see in the problem that she wants to choose a brother first and then a sister, or a sister and then a brother, or if she just wants to choose somebody for the first place, second place, whatever. I don't see it anywhere here. So no, order does not matter. We are dealing with a combination. How many total people do we have in this problem? Well, we have 3 brothers and 1 sister, which means we have a total of 4 that we're choosing from. How many are we choosing from this pool? Well, we're choosing 2 to go along to the Texas State Fair. I don't know how the other 2 siblings are going to feel being left out from this trip, but hey, this is the math problem here. So the combination is we're choosing from 4 and we're choosing 2 from those 4. Using the TI-84, you're going to type in 4 math, go right to PRB, choose the combination option, hit 2 for the R value, and there. We have 6 different ways of choosing 2 people out of 4 for this road trip. So there's 6 different ways of choosing 2 people, 2 of her siblings, to go on this road trip. and just move this box, and there it is. And that's it for you try number 7. And that's it for 5.02 notes. If you have any questions, you can email me or call me anytime after 5 p.m. for both email and phone. I tend not to answer. If it's an emergency and you really need my help with something, then contact me through phone and I'll see what I can do. Otherwise, just make sure to email me and let me know what y'all need. Okay? So that's all I got. Y'all have a good day. Take it easy, everybody.